Poojan, are you live? Achal, are you live?
Yes.
Okay, great. Chalo. Nice.
Can you see who's been muted and unmuted?
No.
Okay. Hi, welcome everyone. We just give people a few more minutes to log in. We'll start at about 3:03. Okay, it's 3:03. I think we'll get started. So first of all, welcome everyone to this webinar. Hope everyone is staying safe and keeping healthy. Thank you so much for being here on this Friday afternoon. And again, thank you to the Spark group and specifically Mr. Patnaik for giving us this opportunity to share some of our learnings and experience with all of you. So let me just introduce you to the speakers today for you guys. We have Achal Trivedi, who is the head of product marketing. There will also be Nehal Savi, who's the head of software sales. And then I am Poojan Khilani, and I'm the product head for Motwane. So today we'll be talking about something that's very, very relevant, I think, in today's time. Essentially, it's about adopting technology across the spectrum of work to really protect ourselves against the stoppages of work, or at least providing a certain safety net to our operations. Digital has allowed us to move forward and move ahead in a lot of ways, personally and professionally. So today, obviously, with the scenario, with the lockdown, the pandemic, we have meetings over Zoom, Skype, WebEx. We treat that as the new normal. For schools and colleges, education and teaching is also moving over to some of these online platforms and services. And obviously, a lot of these digital tools have impacted not just the world outside of us, but also our world, which is the electrical world. Right. So today we just want to show you how, or talk through how we can actually advance our work, and actually our technologies can help us transition us into a digital and online world. So before we get started, just a couple of housekeeping things. Please feel free to ask questions at any point. Whether it could be regarding something, the presentation that we've got in front of you, or it could be something related to it as well. Feel free to put it in the chat window. We have a moderator who's actually monitoring that feed, and we'll try to get those questions answered as best we can towards the end of the presentation. But again, please feel free to ask as many questions. I think the more interactive we can make it, the more questions we can help you guys get answered, I think the better it will be and the more beneficial it will be for all of us. Right, so that being said, let's get started with today's topic and today's outline. So I think what we'll do is we'll start off with the current, a little bit about Motwane itself, in introduction to our company, following which we'll jump into reviewing some of the current practices and challenges that we all face in some of our work that we do today. To address those, obviously, we believe in a digital future. And so we'll talk through some of the digital testing solutions, along with what we have as a proposition, which is a connected test and measurement world, along with transformer monitoring. And towards the end, we'll try to summarize that with a live case, including some advanced analytics. So hopefully it should be fun and enriching for a lot of you guys. So let's get started. Like I said, we'll start off with Motwane first, right? So Motwane actually, some of you may be aware, has been around since a long time. It's since 1909, so this is the 111th year of the company. And it actually started off as a trading company in British India. It started off with importing and trading, again, a lot of the electrical components and goods. And it played a very active role in its initial 20 to 30 years with the freedom struggle. So what it originally provided was PA systems and radio communication for the freedom struggle. So if you can see the picture on your screen to the bottom left, you'll see Chicago radio on some of the mics that were actually used by the freedom fighters back before independence. So it's got a very rich history since then. And as the company, or post-independence, and as the nation started to open up, the company actually contributed pretty heavily to the growth and the building of the nation itself. So it started off actually, or it moved over into EPC type of business, as well as being a manufacturing company for a lot of test and measurement goods. And then over the last 4 years, to move your eyes over to 2016, is when we identified a certain evolution in this industrial world that we're currently living in. And this adoption of technology actually led us to introducing a smart street lighting solution and control street lights in any given facility or specific region. Since then, we've tried to address the need to bring in technology into test and measurement and through transformer monitoring as well. And so clearly, I think it's quite evident that we've got a legacy of evolving with time, and serving the needs of the industry, and the nation, of course, and really identifying what these trends are. And I think that is probably the important part, where today we're trying to build and further this legacy of using and adopting technologies which are readily available today, which probably we have seen in the consumer world before. But how do we really apply it to the industrial world, to the industrial setting, is what we're trying to take a look at today. So we'll dig right into the meat of the problems today. So one of the biggest problems today is typically when you have, let's say, a field engineer, and I just want to paint a scenario for you, right? So you have a field engineer who will go into the field, which let's say is a substation, to actually conduct a test with his heavy equipment, which will be, it won't be in the best of conditions. It's going to be hot. It's going to be humid, and that field engineer will typically have 8 hours of shutdown that he will get, through which he has to complete all the connections of the equipment, or the asset with the test equipment. There are tests being conducted. There will be values which will be noted down, stored in the device, or noted down in his notebook. And this entire process, in teams of 2 or 3, could take an entire day to actually complete and get done. At the end of the day, he'll pack up, and then either at night or the next morning, he will travel to the second site. And this cycle repeats, where he'll have an 8 hour shutdown, conduct a test, enter data into his notebook, end of day, wrap it all up, and move over to the third site. And this cycle, typically, which will be on the road, will go on for about 15 days or so. And at the end of which, he'll go into the office, open up his laptop, open up his notebook, load up Excel, and start typing in values exactly like what you see on this screen over here. And he's going to try to read values from one of the pages in his notebook. The 6 will look like an 8. He may or not have noted down the day, the asset, some of the nameplate details, which could also be available. And it actually could be a little difficult when you also have a junior engineer who doesn't have the right experience in creating some of these reports. So they may not know, let's say, the acceptable value or the certain specific standards that could go into capturing some of this data. To draw a parallel, this is actually similar to what also happens when there is live data that needs to be recorded at, again, let's say the same substation. So for example, like what you see here on your screen, will be a typical register that you will see at a substation, where every hour there will be certain values recorded across each of the different parameters. And clearly, just by visually looking at this, you can tell that there are a few issues, right? Just to point a few out, you can see in some of the scenarios where you see some of the values actually uh, scribbled over using white ink. In addition to that, there are some values where a 5 has been written over and a 7 has been written over. Some values have been circled around. And again, like I said earlier, where you can't tell the difference between a 6 and an 8 or a 4 and a 9. And that's just because of the handwriting sometimes of some of the field personnel, right? And again, this is not the ideal scenario. I think more importantly, also, what you'll see is at a time, like if you can see on your screen, between 11 a.m. and 3 p.m., there has been a shutdown in this scenario, and a reason has been written down, manually entered, but there's no real follow up that seems to have been taken place. There doesn't seem to be any analysis that seems to have been done. There is no root cause to really understand what went wrong, how it went wrong, and more importantly, how do you prevent something like this from happening again? I think quite obviously also, this being a handwritten report with certain time intervals, I think one of the challenges is that a lot of the field engineers actually have it pretty tough, right? So for them to actually note down these values on an hourly basis, while it may be still possible during the day, at night, so let's say third shift, which is 11 p.m. to 7 a.m., it's got to be incredibly difficult for them to do that on an hourly basis. So again, clearly there is some serious challenges that any of these operators would face. And because of these operators facing the challenges, obviously these are challenges that are really felt and escalated across the entire plant, if it's there, or if the substation or circle, or possibly entire utility, because this is a pretty standardized, consistent approach with how some of these test data are actually recorded. Right. So you've got, in the first case, you had your Excel report, or pretty much a handwritten report. In the second case, you have your live hourly readings. And what does all of this lead to, right? Typically, all of this will lead to a 20 to 200 page report or so, which will be a Word or PDF file, which will be very focused on one specific assets. But importantly, it'll be for one single point in time. So you actually don't have the previous results. What you do have is the values as they were tested, recorded, and the day it was actually entered into this report, fair record keeping, and for obviously presenting to end customers. So clearly, again, there is no evaluation, there is no linkages, there is no deeper analysis that is done. At times, I think we might get lucky where there might be certain recommendations that might be made, but oftentimes it's buried somewhere deep inside a 200-page report, which makes it a little difficult to actually go through and read. I think importantly, also, we spoke about single point in time, but the report is also shared typically 20 to 30 days after the test data has actually been captured. And this in itself actually presents a pretty difficult task when you really want to take immediate corrective action, or you want to know of any danger or any alerts or alarms that you may need to actually change your course of action. So you don't actually know a lot of information. It's a little delayed, or there is a lag, and you can't relate it or correlate it to some of the other parameters and values that you've actually got. And so this clearly leads to some very clear and obvious challenges. I think to us, we can broadly classify them as being, challenges related to people, process, and technology. Uh, and really, over the last 2 months or so that we've seen, because of COVID, it's created a whole host of different challenges. So while the initial challenges always existed, they've actually only been increased. Why don't we look through some of them? So, from a pre-COVID standpoint, if we were to look through it, from a people standpoint, each tester, as we saw, clearly spends a lot of time on non-value-added activities. The Excel report that you see, the first time that they're writing it down in their notebook, then transferring it to an actual digital medium, that's a data entry job, which typically we have an engineer doing. Uh, Besides, it's also tough, hard work for the engineers to be in the field to capture some of this data. So again, there's a lot of time that's being spent on non-value added activities. I think importantly, all of this is typically driven by the most experienced tester that's a part of the group. And so clearly we have to wait, and this means typically that you'd have to wait for some of your junior engineers to actually get up to speed and learn really the ropes of how these tests are conducted, what certain values mean. There's a lot of what we call tribal knowledge, right? There could be certain instances when no, this, whenever you have this piece of equipment, whenever you have this asset, make the connection 3 inches to the left and 2 inches to the right, and only then will you get the right reading, right? This is quite typical of what we've all seen. So there is very limited institutionalized knowledge, which is typically shared with a lot of the engineers, at least from a training mechanism. And that brings us to the third point, which is actually there's a very detailed training method and training mechanism that each of the teams need to go through to train a lot of the staff, because again, they're not accurately skilled or appropriately skilled straight out of college. So that creates again a whole host of other challenges. Uh, then coming down to the process standpoint, clearly, like we saw again, that was one sample of the reports that you would generate in a scenario where typically you'd be working with multiple testers or multiple testing teams. There's multiple reports, multiple frameworks that you'd actually end up dealing with for one single asset or one single substation. And that itself leads to a lot of challenges, right? The obvious one being that you can't actually analyze something which is not standard, or you can't really work or work retrospectively to understand a little deeper about what's actually happened. Secondly, I think the challenge is around testing being reactive and time based as opposed to usage based. So today, they will know that there are certain tests that need to be conducted on a monthly basis. Some will be on a quarterly basis. Some could be on a 6 monthly basis, and some would be on an annual basis. And obviously, there are also those parameters which we're tracking on a real time. And then all of this leads essentially to highly siloed and isolated operations, because what the substation is actually capturing is one set of data. What is being captured by the test engineer or the field engineer, by the testing contractor, typically in the field, will be another set of data. Now, all of this data may sit either at the substation or at a central office, but there's very little sharing of information that happens, as opposed to what is really possible, right? Uh, and again, the last bit being a technology challenge, which is just like we saw, there is a manual recording of entry, which is highly prone to errors. So again, a 5 could be a 6, a 4 can be a 9. Uh, Things are white inked, and again, there is no deeper dive into understanding why certain values are coming up. Perhaps there is a trend which could have been overlooked just because of the stress of the work and the urgency with how some things need to be done. Uh, because of this, there is also a lot of duplication of efforts in some of the reporting practices and reporting standards, and that itself also can cause certain issues. So, for example, of course, you uh, may have certain activities that you want to do, whereas on the other end, a testing team is pretty much at the decision point to say, do I go to transformer number 1 to conduct my tests and actually understand what was wrong, or do I go to test number 2? And so that the decision point actually is what should be eliminated, because it should be going on in a very methodical and prioritized format. And I think perhaps most importantly, like we touched upon earlier, is that there are no trends, there is no root cause analysis that is offered right up front. While it may be possible to do it manually, the problem is you would need to do it manually, right? So let's say you were looking at some of these PDF reports, you had to get them over the last, let's say, 5 years or so. In addition to that, you would want to look at your register itself that you have at the substation, and suddenly you're looking through a lot of manual pages to actually understand what really the problems are. And again, this is pretty much like shooting in the dark, because you don't really know where is the biggest problem. A lot of this information about, again, where is the biggest problem is typically not institutionalized, so it's whoever screams the loudest gets the biggest eyeballs, right? And those are real significant challenges when we're talking about critical infrastructure and critical assets, such as transformers and other substation equipment. Now, that was in the pre COVID world. In the post COVID world, not only do we deal with a lot of those issues and a lot of those challenges, but importantly, they're only exaggerated further, they're only enhanced further. And from a people standpoint, probably one of the most important ones today, considering the safety of a lot of our personnel, a lot of our team members, is the restricted mobility through containment zones. Trying to jump through hoops, trying to get necessary permissions to ensure certain areas and regions are able to function and operate normally is a challenge, and that poses a serious risk. So, regular maintenance activities have to be put on hold, or even if they're conducted, there is serious challenges that we need to go through. And importantly, because of these containment zones being present, because of the restricted ability to transport some of our teams, there is limited manpower that we have on our teams ourselves, because we're trying to limit the risk that even they're operating in. And risk mitigation really is the game that we're trying to play right now. Uh, from a process standpoint, clearly this also means that we need to follow certain protocols, which actually means that it's a suboptimal process and it's a suboptimal operation that we're actually following. While yes, it is necessary to follow those to ensure the safety protocols, but clearly there are certain inefficiencies that are building into the system. And so the question is really, how do we address some of those challenges, right? When it comes to these process related issues. To add to this on a technology standpoint, like again we just spoke about, you have certain records which are stored quite discreetly across different regions, across different locations. To actually analyze and understand them when they're not available digitally, how do you do that when you actually can't go from point A to point B or point C? And again, some of them may be containment zones as well. So again, the fact that you don't have a lot of these records in a digital format makes it that much more challenging to actually use and make a difference with. And I think a lot of these issues that have come up in a post-COVID world really has actually indicated and again emphasized what our general premise is, that I think we as a team, as a structure, is probably a little underprepared for accessing data anytime, anywhere. And so the real question becomes is how do we really solve some of these challenges, whether it's in a post-COVID world or a pre-COVID world? Because again, I don't think any of these issues are going to go away no matter which world we were living in, whether it was the one 2 months ago or today. So, really, how is it that we think we'd want or we would be able to address some of these issues, right? So you started off, if you look at the extreme left, you started off with basically getting and working with heavy equipment. Sometimes it was portable, sometimes it was not. Sometimes it could go up to 20, 25 kgs or so as well. And you'd have teams of 2 to 8 people or so, typically going into the field and working in hot conditions. Slowly over time, we've actually evolved it into being slightly lighter, slightly smaller, slightly more robust, where it has wheels and you can wheel it around in the substation as well on a pretty difficult terrain. To then being able to record some of these parameters and save them really on your devices itself. So that way, maybe you can try, or a tester can try to avoid the process of actually noting it down by hand, but it's just stored in the device. But that still doesn't address the challenge of the tester having to walk into the office about 15 days later, open up their PC, and then connect their device to their PC to pull in all of this data. Clearly, there's a lot of issues with that as well, right? So again, for example, the user has to be on the PC, which has his software with the same specific equipment that was used in the field on site to actually pull out that data. And secondly, and I think which is also a big issue, is that tester really going to remember, or do we want them to remember, was it record number 33 that I need to pull out, or was it 34? So again, there is a lot of issues and challenges when it comes to that. Um, Even once the data has been pulled out of the device, it's typically going to be stored in the PC, or sorry, on the PC locally itself. It's not that if data can be immediately shared across different vendors, different contractors, different people that are accountable and responsible and should be informed of this information. It's very specific, very localized. And again, you're still not looking over historical data. It's only the data that you've actually captured from the device. So really, does this address the challenges that we had in a post-COVID and pre-COVID world? Perhaps not, right? And so the answer does seem to lie in the paperless reading and digital data capturing, as well as the real time monitoring and analysis of a lot of this information. And while we've spoken through the past and the present being desktop applications, we need to really think towards the future as to how do we believe the post COVID world is going to look, and how is it that we can make the right use of technology, the right application of this technology to make our world a better, safer place. I think one of the most beneficial aspects of using paperless reading, and again digitizing a lot of the data, is the commonality in storage and accessibility of a lot of this data. Um, and that in itself actually solves a lot of the problems. So you could imagine a world where you have a test engineer who goes into the site, they make the connections up like they always do. But this time, instead of actually recording their values by hand in a notebook and then waiting for 15 days to transfer that to Excel or Word and then creating a report, instead you can actually cut through all of those non-value added activities where you can use, let's say, a mobile app or a tablet app to capture some of this data. This application could have, for example, information on the asset that you're testing, who you're actually testing it for, whether it's a utility or an industrial customer or a commercial space. And you actually have record of the previous result and the time before that. So the test engineer, who again is an engineer, is someone who's not just doing data entry and analyzing results 15 days later, 20 days later at the time of creating this report, but they're actually analyzing it at that point in time itself. And that just makes the speed to decision making so much better. More importantly, even when this data is being entered, this data can be entered into an application which is not just used by that single tester, but also other key team members, other experts within their team, but also within the end customer's team. So, for example, if the testing team itself wants to know how certain issues can be tackled, you don't necessarily need your most experienced engineer or the subject matter expert on site every single time. And clearly, you can't, it's difficult rather to preempt a lot of these issues. So, what you can always do is actually have someone sitting at a separate location viewing the same results that you have in real time, and you can actually understand how some of this data is being looked at how it's being captured, and really what exactly are the issues that need to be solved at this site. Coming down to real-time monitoring and analysis, that clearly that clearly targets the issue that we have when it came to the live hourly report that we saw, which was typically a handwritten record register kept standalone singularly only in the substation with access only to the substation. Instead, what if you had the same application actually capturing this information in real time at the same set hourly or minute settings or frequencies that were preset, and you actually got an alarm or an alert for it, which was again never possible until now, until and unless, let's say, your oil temperature indicator or your relay, for example, actually sounded the hooter, sounded the horn, and then following which it actually tripped. So there's a lot of redundancies that it's actually skipping, which have been built into the system for serving a certain purpose, which again, this real-time monitoring and analysis solution can actually help address. So if we are going digital, really, why is it so important, right? And to summarize a little bit of what we spoke about in the previous slide, it really comes down to paperless work, right? And the moment we are able to go digital, right, and move away from using papers and documents and any handwritten sheets, we're really empowering engineers to do the engineer's job. The engineer's job is to problem solve. The engineer's job is typically not going to be to enter data, to create a chart, to generate a report. Those are all just side activities which help really an engineer to understand what the problem is and problem solve that issue, right? Understanding the root cause, asking the questions, knowing why, and really solving that problem is what they're really bound to do, and really what we're really hiring them to do. All of this really is simply to help the entire team, which could be the testing team, it could be the industrial team, it could be the utility, to just simply optimize operations. And this optimization essentially works with people, process, and technology. And again, it addresses all three of these challenges. Most importantly, all of these are really meant and help any end user to reduce downtime, because now you're able to focus on the specific issues, the specific problems, and find answers to those specific problems. Instead of, again, like I said, shooting in the dark, instead of not knowing where to look, and instead of just following a simple time bound approach or a time bound schedule, it's actually following a need based schedule. So you're moving away from a highly reactive approach and a highly schedulized approach to a proactive approach to really understand and address some of the key issues that any asset or any part of the grid could be experiencing. Most importantly, the digitalization of a lot of this data is actually helping teams at a significantly larger level make better decisions. Today, or through these applications, you could have data which is digitalized and accessible from any platform, web or mobile, from anywhere, no matter where in the country you are, or even maybe outside the country. You can still access and make decisions based on data. Again, it's not based on tribal knowledge, like I said. It's institutionalized knowledge which is available to actually make the right calls and make the right decisions. It could also mean that we send the right people at the right time at the right place. So, for example, before a team goes out to test, they could it would be great if they could actually know what exactly the issues were. So they go in with the right set of tools, the right equipment, maybe the right team members, right? And probably the right toolkits to really address the problem itself, as opposed to going in, spending maybe 4 to 8 hours to understand what the problem is, then trying to think of a solution, then ordering supplies, and maybe 3 or 4 days later actually fixing the problem. And that's probably in a good scenario. So the idea is that we can use digital tools and digital technologies to really help with automation and analytics to make better decisions and to drive improvements in our operations through operational efficiency and financial efficiency accordingly as well. So really, what is the solution? I mean, I think we've walked through some of these ideas already so far. But what are the key elements of what this solution possibly can be when we talk about digitization or digitalization? I think it essentially starts off with simplified data collection. To add to that, it's also standardized in a format that is easily viewable, easily accessible for all team members, no matter where you are and who you are. This also means that it's authentic digital data, wherein a 4 cannot be read as a 9, a 6 cannot be read as an 8, a 1 p.m. will not be mistaken as a 1:15 p.m., and certain issues already obviously associated with those. So there's deeper trust that we are automatically able to build in to the system and in the process that we typically follow. Importantly, a lot of these systems are actually automated. So now, again, even the substation engineers, they don't need to do the tedious task or the menial task of simply looking at certain uh, at readings and then recording them in a register. All of this is actually happening in an automated manner, in an automated fashion, and there are real-time alerts and real-time alarms that are being pushed out to the right personnel to take the right step and to take the right action. All of this in a slightly longer term perspective, given the right knowledge, given the right information, it allows experts to conduct certain analysis, like trend analysis over time, for example, to really understand what the system is, how certain assets are behaving. Are there specific design issues, for example, which could be causing certain challenges? So there's a lot deeper that we can dig into the moment we have a lot of this data available. And most importantly, like I said, where we are today in a reactive maintenance or a time based maintenance scenario, we can progress and move into the predictive maintenance scenario. And really, this is a journey of progress that we would have to make. So if you look left through right, it starts always with the data itself that we're capturing in the simplified, standardized format, which eventually ultimately leads us through these individual guiding steps to the predictive maintenance holy grail that we'd want to reach. Now, all of this, like we've spoken about, essentially means there's better resource productivity, which means it's better labor productivity, it's better equipment productivity, and that simply means better customer satisfaction. And importantly, all of this can always be shared and integrated with different kinds of applications any end customer or customer may want to use. So, for example, if there is an end customer, which is an industrial customer, which has their own enterprise resource planning or ERP system that they want to use for, let's say, reordering certain tools and reordering certain components, these sorts of applications can always push data into ERPs. And for this purpose is actually exactly what we have created at Motwane, our own digital test data platform called Motware. And Motware, again, is what helps any end user walk through the basic steps of digital data capturing all the way through to trend analysis and predictive maintenance. And again, this open platform becomes extremely important because of this, because we recognize, and I think all of us should recognize, that there is no singular platform which is going to be able to solve every big problem or every small problem that any user may have. We've got to focus on the right problems, the right challenges, and address them in the right ways. So really, how are we solving this problem, right? What does this problem mean? And what are the different ways that we can use to solve some of these challenges? So if you look through this, obviously this is the image of a transformer on the left-hand side. And when you look through the three methods of actually capturing data into Motware or a solution like Motware, there is the first method, which is a manual data entry, which is you can take, let's say, any piece of T&M equipment out into the field, make the connections, conduct the test, see the values on the screen, and now again, instead of recording it in a notebook, you're immediately entering it into the mobile app. And this app, of course, has the nameplate details for the specific transformer or any specific asset that you're actually working with and testing and recording data on. While this is a manual data entry, and this can work with any device, any make, any manufacturer, any type of test for the most part, what, in addition, as Motwane and as a TNM player, what we have also pushed for, which we believe should be a standardized approach, is really enabling our test and measurement devices with Bluetooth so that they can interact with the mobile app. And again, we encourage several other players to actually integrate with our application to simplify the life of the end consumer and the end user. The moment we're able to tap into some of these technologies to actually, again, not even manually enter this data, but simply push a button and actually sync, you're able to pull in data from the testing device into the mobile application. And all of this data that we've captured, whether manually or through the connected device, is stored on the or is stored on the mobile app. And once it connects to the internet, it's actually pushed into the Motware platform. So that is essential and captures the offline testing portion of the testing process and procedures that we have, which again help at least address a lot of the challenges that we looked at in a pre-COVID and a post-COVID world. Now, when we talk about the automated or live monitoring of a transformer, we have built out, or we've got a device which is essentially a multi-monitoring device, what we call the IoTX device, which essentially helps you monitor specific parameters in real time on the transformer itself. And again, this simply connects to your sensors that you have on the transformer. So they could be, let's say, your oil temperature, winding temperature, etc., which captures into this device and periodically will push it into the Motware platform. So to summarize, right, there is a manual data entry, there is the TNM or the test data entry that's coming in for the periodic tests that we do conduct. And then there is also the live data that we're capturing through our multi-monitoring device. And all of these three data sources are really being aggregated into one single platform, which we've called Motware, which again helps you understand the overall health of the transformer. So now it's not dealing with one single point in time of data. You're not dealing with only offline testing or only online testing. You're not dealing with handwritten reports wherein there could be certain issues and discrepancies, and frankly lack of transparency in the data that is being captured. It's true authentic data which is coming in a standardized format, in a standardized structure, which can then be analyzed for the trend analysis to identify the issues and further up into predictive analysis. And we'll get deeper into some of these methods of entry now. So we'll start off with the connected solution, which is what we call the connected test and measurement approach. Quite simply, it's exactly like what I said. It's pretty much three components to it. You have a test equipment, for example, where you see our 5 KPI device. You'd have one of our devices, which is Bluetooth enabled. The test is conducted, the values are stored on the device at the push of a button, and when you have the mobile app open in front of you on your mobile device, you're able to sync and pull in the data in real time. You can actually view it and say, yeah, okay, this looks okay, or no, maybe this needs to change. And you can reconduct the test, you can resync your device to pull in the data again. And the moment you push the button, which is to submit a test result, you're actually pushing it live into the cloud, which goes into Motware. And so while this entire operation and this process is conducted by the field engineer in the field, the results are being viewed by any person at any point in time that is obviously authorized to use some of this information. And what I mean by that is you could have that subject matter expert really sitting in one single location, but being able to address questions and challenges that a lot of individual teams working remotely may not have answers to and may need help on. And so again, this brings everyone on the same page in real time, and in a highly customizable and highly customizable and highly standardized format as well, which is extremely easy to go through, as we've seen, and extremely critical, right, to actually walk through to the end, which is your trend analysis and your predictive analysis. Right. So when we've spoken about this digital test data platform, which is called Motware, what exactly is it, and how does it work? So a lot of the challenges that we had seen before is what this application or platform is really trying to solve. So most importantly, you can view things in real time across any application, across any platform, which could be web or mobile, and even on web, it could be on any operating system on any mobile device. So what that means is that it's essentially a SaaS platform, and SaaS is software as a service, wherein it's a cloud-based application. And this, because it's a cloud-based application, it allows the entire application with the data to be highly scalable and highly flexible with actually its use and its services that it can provide. This also means that you can actually integrate this specific application across different other applications that may be in use. So maybe there is another application that you or your teams are using, which could be for, let's say, attendance recording. It could be for uh, managing certain tools or toolkits. It could be a third-party application to help you capture some of this test data. Again, the idea for an application like Motware is essentially to leave it very open and very customizable to actually integrate into any other application that you may want to use. And I think most importantly, this is a highly specific platform to address very specific needs and requirements. On the other hand, these specific needs and requirements are actually not just with one kind of segment of customers, it's actually with a lot of different segments, right? So we look at industries where they have the same challenges, similar problems with their maintenance teams. OEMs have the same issues when they talk about service and warranty operations. And then obviously there is electrical contractors as well as utilities. So this problem persists across a range of different segments, which can be solved and resolved quite easily and seamlessly through one single platform and one single access. And again, why is this even important? If we if we remember where we started off with, which was the standardization of data, right? We want to get data which we can trust, which is factual, which is automated, and actually timely to help us eventually advance into the trend analysis and the predictive maintenance or predictive analytics. And so these are just the simple building blocks that we actually need to be able to get there. But we have to start somewhere, and that somewhere starts with manual data entry. It starts with the connected product, and it starts with the multi-monitoring device for transformers that we have called IoTX. Right, so now that you've captured all of this data into Motware, what exactly is there that you'd want to do? What does trend analysis even mean, right? Quite simply, trend analysis simply you being able to compare uh, information on different assets, different tests, different locations perhaps, and understand how they're really functioning. Are there any correlations that an expert or an engineer is able to understand and resolve? Are there any specific patterns? Is there an ascending pattern? Is there a descending pattern? Are there certain patterns that are being followed due to weather? So there's a lot of questions that any of us may have when we're actually looking through the data, which while today it's not possible, an application like this helps you do that because you're starting off in a very standardized format and a standardized approach. What you see here in a chart, which I hope is clear, um, is actually a hydrogen value for DGA for two different transformers in two separate industrial plants in one single location, which is Agra. Now, the question is why do this, right? Why does it make sense? Well, maybe you have two assets in the same city or the same location, which means that from a weather standpoint, they're following the same process. Humidity, etc., is the same. Weather cycles are the same. Maybe perhaps consumption patterns are going to be similar, but you could have two transformers which might also be similar in terms of a design, but they may have two very different operating conditions. They may have two very different results when it comes to some of these tests that we're conducting, which frankly you may not be able to realize or simply gather from the Excel reports or PDF reports that you're trying to get. And the moment it comes into Motware, which is a standardized platform, you're again able to identify what these patterns are. And so you can tell, well, okay, if there is a certain pattern that it's following, if this pattern is being observed across multiple transformers in the same region which have similar ratings, maybe that's not a cause for concern. On the other hand, if there was one transformer which was acting up and that was an anomaly, perhaps that is something that you'd want to investigate further and really deep dive into what could be causing some of those issues. Another level of analytics that there could be is actually in understanding a lot of the assets that any end user may have in their system. So, for example, a utility or an industrial customer could have multiple assets in their application, which again is Motware. And what a solution like Motware allows the end user to do is actually summarize a lot of the data or metadata for some of the test values that have been captured. So for example, you could have your manufacturer information, you could have the test information, you could have testing engineer information, you could also know how many times have tests passed or failed. So what you see in the image here, which again I hope it's clear or visible, is for a specific manufacturer, for a specific test type, how many tests have actually failed and passed, which is exactly what this table out here is trying to show you. So if you look at the second column, it says asset manufacturer, and you could look top through bottom. There are certain specific examples that we've taken in here, which correlate to specific assets, of course, with their own specifications, with their own details, with their own, of course, loadings and operations. But then there are also certain specific tests which we're conducting on it. And importantly, you'd actually want to know whether these tests are actually passed or failed. And again, this pass or fail is an important value, or it's an important parameter, because the application, and again, Motwane does this quite well, is the ability to actually identify if certain values that have been input through certain tests that have been conducted, if they meet a certain standard or a threshold, or they don't. And this threshold or this value can be highly customized. So while there may be someone who wants to follow a certain standard, someone may have which their own standard, which could be their internal let's say company standard that they have to follow, or utility standard that they have to follow. And the application itself allows you to really understand whether certain values are going to pass or fail. And this, again, in a summarized manner, in an easy to read manner, allows any user to really quickly identify, are there any assets which are constantly failing or have failed more than the others? Is there any manufacturer that we can go to and work with to understand what the deeper problems might be? Is there an issue that we need to work on the design, on the operations, on the maintenance? But essentially, how do we improve the operations? How do we make it more efficient? How do we reduce the downtime? How do we increase the uptime? All of these results that we've now captured, essentially, whether it could be through manual data entry, whether it could be your connected test and measurement product, or it could be through your IoTX device, all of this data comes into Motware. And not only can you analyze it through trend analytics or through creating your own customized pivot table, but you could also just generate a report right from within the application and share it with anyone you'd like to. Obviously, you can share this via email. You can download in Excel. You can download in PDF. It can be a highly customized format, highly customized template. And you actually get all of this with a few clicks. So really, it's very convenient, or this makes it very convenient to move away from where we started off with. And again, I want to kind of go back to the beginning. Where we started off with was a notebook, Excel, and a handwritten report, which was three of the pillars in how reporting was conducted and formatted in up until now, can be done quite easily, seamlessly through digital tools, digital technologies, which are quite readily easy available and possible to do. And importantly, it brings you one step closer to the predictive maintenance cycles, to the predictive maintenance schedules. And all of this is possible through the digitization of data. So you have reports now, like you're seeing here, that you can generate on the fly with a few clicks. There is analysis that you can do from within the application, whether it's a trend analysis or a highly customized pivot table that you can create from within the application. And some of these reports and some of these analytic tools is what you can use to even generate and auto schedule reports for you. So now you may not even necessarily need to put in someone to actually manage this data. So it's not really creating more work. It's actually helping you solve and address the clear challenges that persist and that are present today. So with that, I'm going to hand it over to Achal Trivedi to walk you guys through the transformer monitoring part of our application.
Yeah, thank you very much, Pujan. And good afternoon to all the participants for the patient listening to the solution and challenges what we discussed regarding the maintenance of electrical assets. I would like to take you through the section of the solution what we are trying to offer. That is for monitoring the live conditions in which the transformer is operating. So mostly it's the real-time operating data, and which also forms a very important element where the data comes at a very immediate frequency as compared to the traditional maintenance. And those operating parameters and some of the critical parameters within the transformer can be monitored and correlated to give out a lot of insights about how the transformer is functioning, what are the boundary conditions, and how the vital parameters within the transformer are behaving in respect to those operating conditions. So I take you through the architecture of how the solution can be implemented. So in the left hand side, you can see an image of transformer where we have the multi-monitor. When it's customized for the transformer monitoring, we call it as IoTX. So essentially, this is a edge processor which has got a good edge computing capability. Typically, this hardware is the gateway to a lot of parameters which we can take from the transformer operating conditions. So all the sensors which are mounted on the transformers, or maybe few more parameters which can be monitored in the brownfield case, where we can install few more sensors to capture some of the important data about the transformer live condition. So the hardware connects this to the sensors through the wired mains, and now this data is internally kind of processed, and then it actually is pushed to the cloud platform, which is the Motwane platform, which has been explained by Poojan. So typically this is over wireless, and the way the offline test data has been properly structured, same way all this data goes with the timestamp, and it is mapped to the transformer which on which this particular controller has been installed. So this data goes and sits into the database of the platform. Now with this, what we get as a benefit is, if we see the offline testing data as and the kind of real-time operating data in isolation, then there will be some kind of limitations in terms of analysis what we can conduct. So if we are looking at some kind of root cause analysis, then it is really important to understand both the patterns thrown out by the periodic testing of the asset, as well as in what conditions the asset is getting operated. And the correlation of both of this data gives really some of the valuable insights into understanding not only post issue condition, but it can also preempt the user about any potential challenges with any of the vital parameters going or crossing the limits. Now when we speak about the architecture, so we can have multiple assets like transformers in this case, maybe from one substations or across the larger geography, connected to a single platform and mapped under a single organization. So in terms of scalability, the entire solution is highly scalable. Right from the processor, what we are talking here is also flexible in terms of capturing different kind of parameters, as well as the entire solution has got that kind of scalability to serve a larger volume of assets at a single point of time. So just a gist of the parameters, and this entire solution has actually two parts. One of them is monitoring, and then based on the offline and the monitor data, we can carry out few advanced analysis on basis of that data. So right now, in terms of monitoring, what we typically capture from transformer are the load parameters, that are the currents in the load end, voltages, the ambient temperature in which the transformer is operating, essentially the top oil temperature, winding temperature, and oil level. Apart from this, we also capture the ambient humidity as well as the location in which the asset has been installed. So these are the basic parameters what we integrate, and beyond this, we also integrate some of the transformer protection devices which are already mounted on transformer, which actually also gives some indication about any incipient faults. So this devices are also the status of these devices are also captured by the edge processor. Beyond that, we can also integrate the energy meter data to this, where we can then do a lot of other analytics on the load profiling and the type of load which is getting connected. So all the parameters which energy meter is capturing can be used for a lot of trend analysis. Beyond that, we also can integrate different devices like tap position indicator and so forth, so on. The statuses of some of the other assets within the substation can also be integrated. So we have a very highly scalable and customizable solutions in this particular platform, including the software and hardware part. So I'll straight away take you to our live case where this has been installed. So this is one of the installations where the solution is actually implemented. So this is typically a power transformer in the substation of utility. So it is a 10 MVA transformer. And typically what we are monitoring here is the load currents, voltages, and the oil and winding temperature. Along with that, we also monitor the humidity and the ambient temperature. So this present analysis, what I'm trying to show you is for the 6 month of data, which we will try to show you what all functionalities we can provide through this solution. So the one of the very important parameters is the loading of the transformer. So since we are capturing the data in real time, so we can do a lot of load profiling where the average daily load pattern phase wise is plotted. The peak load, average peak load in a particular month or in a particular period can be also plotted. This essentially will give a good idea about how the transformer is getting loaded at a different period or maybe at different seasons. And we also plot the percentage loading of transformer per hour or over or the average percentage loading. So all this load profiling can help in deciding about whether the transformer should be, in case of future expansion or load connections, whether this transformer will be capable to handle those kind of loads. So typically the base load and peak load segregation over a period of time can also be analyzed based on the load profile of the transformer. Another important analysis which can be done is to understand the unbalance in the each phase. So you can see the percentage loading phase wise along with the overall unbalance on the transformer contributed by each phase. So typically in case of a distribution transformer like in the substation, the load connection is something which is decided by the loading is again a function of the usage by the consumer. And the scenario also is slightly similar even in the industrial setup, where based on the different priorities and process cycle, even though in the design phase, typically the loading are being done based on loading it in the balanced condition, but practically it's really difficult in different scenarios when the production demand is high, when it is running in a low, where some of the plant is in shutdown. So we will have different scenarios in which the transformer is actually getting operated. Now, another important vital parameter about the transformer is the temperatures, which are easily monitored through the temperature sensors. So typically, there are two important temperature parameters which are monitored: is the top oil temperature and the winding temperature. Now, based on the type, application, and configuration, we will have multiple such sensing points. So as I mentioned, since the hardware is scalable, we can have this customized for different configurations of the transformers. So typically you see here is the trends over a period of time, where you have at the bottom end is the ambient temperature. So that is continuously trended, and what we have plotted is the top oil temperature along with the winding temperature. Now you see two more curves, which are actually the limits of the maximum oil and winding temperature which should be allowed. Typically, in terms of protection, when we see in OT and WTI, these are actually fixed at particular temperatures based on standards, and even as per the recommendation by the OEM based on his design evaluation. Typically, but there is, as we understand that the heat generation is a function of loading, and losses happening within the transformer. The heat recovery is also a function of the cooling technology, cooling method, as well as the ambient temperature. So here you see that limits as varying limits here, and this can be also customized based on the recommendations from the OEM or user. And typically these are all monitored in the platform, and these limits can be set where this can send the pre alerts before the these parameters hit the values which essentially create alarms or triggers. So we can have this values as a set point, wherein this will be used to actually generate pre alerts to the users. And the beauty of the solution is this data or this alerts are accessible by the subscribed users, and this is really readily available on the move at any time, at any point of time. You don't need to be present in front of in front of the monitoring solution what you have in substation. So this is readily available, and all these alert messages can also go to the entire subscribed users in terms of their design levels, and hence the events like this are reported directly to all the stakeholders who are responsible for maintaining this asset. So and these limits are also customized, as I mentioned, as per standards, and this can also be customized based on the user requirement, based on the condition of the transformer, and kind of aging which has kind of happened on the transformer. You can adjust these limits to give you pre alerts. Now coming to the analytics part. So typically in the previous graph we were trending it live, but over a period of time this data helps us into actually doing a prediction of when this particular kind of event can occur. So typically since the operation of transformer happens at different loading conditions, it's highly dynamic. So the data over a large period allows us to see at which particular loading percentage and at what ambient conditions this value is changing at a what rate. So based on this sampling of data based on certain categories, we can also predict when this value is actually going to hit, if it is operated at certain percentage with certain ambient condition, when it's going to hit the limit. So this can send an pre-alert to the users to either to see whether the cooling system is turned on prior to it actually hits the temperature, or maybe to take some kind of corrective actions in terms of possibly adjusting the loading on that particular transformer based on the scenario or control what they have over the loading part. Beyond that, this system gives you the dynamic copper loss. So typically, these are very beautiful combination of the periodic data what we capture and the live parameters. So this particular functionality tells you the dynamic copper loss happening within the transformer. Since we are monitoring in real time the load conditions, we have the updated values of resistance. We monitor the tap positions in a live situation. So here we can kind of incorporate two variances which actually have the bearing on the copper losses. One of them is the temperature impact on the change in the resistance value, and second is the aging impact in the change in the resistance value over a period of time. So both these combinations can give you the real time dynamically the losses happening in the transformer in the windings. Now this typically will maybe help in a scenario where if there are identical transformers, one is in standby, another is operating, or both are actually sharing the load. So based on this kind of evaluation, it could be decided that which transformer takes more loading, wherein we can reduce the losses in the windings. And this typically happens over a entire life cycle of the transformer. So in a short span, the real values cannot be understood, but over a entire life cycle, if this is this data is available, that can help the management or the people to take informed decisions about maybe going for interim overhaul or a replacement, or maybe if there is some expansion coming in place, then whether to continue with the same transformer or maybe to go for a better efficient transformer based on the aging. Now, when we touch upon the aging of transformer, it is essential to understand there are different different technologies or different methods in which the aging of the transformer can be evaluated. Fundamentally, we are using the thermal model for understanding the aging rate of transformer. So based on the monitored parameters, using the thermal model, we estimate the hotspot temperature, and based on the design type, ratings of the transformer, and also type of the paper insulation and the type of oil used on the transformer, we monitor the hotspot temperature continuously. And typically when this particular values are crossing the limits where the depolarization of the insulation is accelerated, so those particular things are captured, scenarios are captured, and then we calculate the aging rate. That is the rate at which the transformer insulation is kind of aging, or the depolymerization of the insulation is happening. Now, of course, there are other methods, but this is one which is on the real time and instant data. And the other techniques can also be deployed, which are part of offline testing, where it can be kind of further validated. But as I said, this is the input which you get in real time. And as all would be aware that once this depolymerization sets in because of the hotspot exceeding the limits, then this is kind of a irreversible kind of damage which is happening. So it's very essential to capture this in real time. So now residual life is something which is based on the design life and at which rate the transformer aging is happening based on the thermal model is what is represented. And there could be further techniques which can be deployed in terms of offline testing, like full analysis from oil, which can give you a better accurate. But this is an indicative kind of expected life based on the thermal model, which is essentially depending on the dynamic loading on transformer as well as the persistence of hotspots temperature for a considerable amount of time, which sometimes occurs when the transformers are loaded beyond the capacity for a considerable longer period of time, or there is some issue with the cooling circuit of the transformer. So I show you some representative images of this analysis on this transformer. So you can see the correlation between the winding temperature, oil temperature, and the hotspot. So this is an curve which is smoothened out at a very small instances. This is calculated, and this curve actually represents the averaged out values over a period of time. That is, this typically is showing you the value over a week's time. So if you go for a deeper granular level, you can see the variations happening very dynamically, based on the dynamic loading condition. And the other curve is about the aging rate, which essentially takes into consideration the hotspot temperature. So typically in case of greenfield, if you have this solution installed from day one, then obviously you get the exact rate based on the thermal modeling. However, in case of brownfield, the previous loading conditions, if they are monitored or recorded, can be kind of backfilled, and we can get a realistic, slightly realistic value. However, from the day this solution is implemented, you can actually see the actual aging rate based on the dynamic loading condition. So this was all about the monitoring part of the entire solution, which essentially talks about digitalization of test and testing of the electrical asset. And the fundamental differentiation of this solution is, since this is a cloud-based platform based on SaaS model, so typically the user does not need to invest very heavily into the capex for actually getting all this infrastructure on his own. So this can be, again, this is scalable. Any issues related to any changes in the hardware or software requirements is actually happening at the cloud level. So without any interruption in the access to the parameters or to the data or for analytics, this system auto upgrades at backend without any kind of discontinuation in terms of the availability of this system. Again, this is accessible to the subscribed users through their smart devices like tablets or mobiles, and essentially this actually gives a very good good flexibility because it's highly mobile. At any point of time this is available. There is no discrepancy in terms of data which is getting captured, because everyone is seeing the same data. And some of the critical alerts which happen at any time can be can be intimated through the SMS or email, and obviously in terms of alerts on the available on the dashboards of this particular application. So that's all from my side. And thank you very much for your patient listening. Thank you, man. Thank you very much.
Yeah, thanks, Achal. Thanks for the session. We have some very interesting questions which have come in. I would like to combine two questions. So first one is by Mr. Sthita Prajanyan Sharma. He's asked, do you have any job done examples in this presentation? And we have another question by Mr. Santosh Bagade, where he's asking, does IoT technology implemented in distribution lines on 33 kV lines to reduce downtime of the system? So, Poojan, if you could take that question.
Sure. Very good questions, right? So what we've actually got, and we ourselves have implemented a couple of these solutions. We've implemented on a range of different transformers from, I believe, 315 kVA up to 10 MVA, and it's also across regions. We've got them installed at a few at substations itself. There's also an installation on a pole-mounted transformer, and a lot of these installations that we have is actually in Maharashtra, Gujarat, and Rajasthan. Across these range of transformers that we're talking about, they're also implemented at utilities. So actually, MSC DCL is one of the utilities that we're working with, along with utilities in Rajasthan. There is also OEMs that we're working with in Gujarat and Maharashtra. There is industrial customers that we're also working with in Maharashtra. And simultaneously, we're also working with a solar power plant, wherein we're actually monitoring their inverter duty transformer. So I think the interesting and exciting case about this, and again, to answer your question, is what's nice to see is that a lot of end customers are actually accepting and adopting these technologies, adopting the digitalization of a lot of the processes that we've spoken about, because there are inherent value benefits that a lot of them are able to capture and they are able to get from this. And again, I would suggest that you always go back to the beginning or the first step, right? The first step is only digitizing the data. Whatever it is that you'd want to do after that, it really depends and is driven by the test data itself. And so that's what a lot of these solutions are helping cater to. That's on the transformer monitoring side. For the Motwane or the application side, along which helps you with the manual data entry, along with the connected product or the connected test and measurement equipment as well. That is actually also being used across utilities, or by contractors actually for utilities across Maharashtra, Gujarat, and Rajasthan. And again, the typical benefits that they have told us about is exactly what we've walked you guys through today, which is the digitization of data, the time it takes to actually capture a lot of this data, record it, and then create a report has been significantly reduced. A lot of times, and importantly, reports are shared a lot quicker, a lot faster. And clearly, there is a comparison being made also with certain standards that is possible through the application itself. So there is a clear benefit and a clear value that a lot of these approaches, a lot of these steps are helping drive to the end user and the end customer as well. And again, this is being adopted across, that we have worked with directly in India. And this is something that is gaining a lot of traction. It's getting a lot of excitement because of the times and the world that we're currently living in today. So we just hope to actually improve and enhance that. And again, if there is anything else that you'd like to know specifically, feel free to ask.
Thanks, Poojan. There is a question and a comment from Mr. KK Murthy. I think Achal, you can take this. So the first question is, do you use optical probe method for WTI or the conventional method? And his comment is, aging depends upon the Furan analysis and DP. If the DP comes down to 200, the transformer is at risk of the failure. So maybe you can elaborate on that as well.
Yeah, so specifically to answer the question, currently it is through the normal methods of taking analog signal, and optical is something which is a part of roadmap. Secondly, it's rightly pointed out, beyond the temperature impact and dynamic loading, there are other methods also which are used in parallel. So as I mentioned, both of them, Furan analysis is something which is done as an offline analysis by taking the oil sample. which the results come after the analysis. So typically this is real time online, and any conclusive decision can be made in combination of both this analysis. So of course there could be some other technology by monitoring some other components of the transformer. So all put in as a combination will give the real concrete the decision. So yes, we are doing a part of thermal modeling, and it can be again validated by offline test on oil by doing Furan analysis.
Thanks, Achal. Another interesting question, Achal, again for you from Subayan Mukherjee. He says, can you please re-elaborate on how the hotspot temperature is being monitored?
Right. So typically there is a thermal model being built based on the type of transformer, typically rating and details about the construction. So there are various time constants which are evaluated based on this. That is from the point of view of what kind of transformer we are trying to implement this model. Second important thing is the dynamic loading condition, which I hope I have already explained that it's been monitored. So of course there are guidelines based on the IC standard, and on top of that there is a lot of other analysis which is put on that particular model, wherein based on the dynamic loading and the kind of parameters based on some of the design parameters of transformer, it actually gives you accurate analysis for that particular transformer.
Thank you. Another question, very interesting one, is by Mr. Parth Gupta. Any data on ROI if this is implemented? Does this allow to eliminate other tests and costs related to transformer testing? This might need an elaborate answer. Nice question.
Like me to answer this?
Yeah, anyone can answer, Poojan or yourself.
Yeah, so could you just repeat once again?
The question is, any data on ROI if this is implemented? Does this allow to eliminate other tests and costs related to transformer testing?
So typically, what happens is we have certain practices based on different type of say categories like industry, utility. They follow their own schedules of kind of maintaining. So when you have this real-time data and the data about the performance over a period of time, and also historical record, which is possible to getting entered in the platform. So we know we can mark the criticality of asset based on at which point it is located, and based on its all historical data on the different parameters through offline online testing. So typically what happens is we can or the organization can actually design a appropriate plan based on the criticality of asset, wherein no asset is actually under maintained or over maintained. So that's how it can typically maybe reduce the cost in terms of doing some recurring testing, which might not be really required for some of the asset. Few of the asset would really require maybe a more frequent testing, and this is something what can be analyzed by the organization, and of course this will this will actually try to reduce a lot of capex as well as opex from their end, because where you don't need frequent shutdown, you really don't need to get into the load shedding and taking permissions based on, and try to enhance the productivity, like if it's even in the industry. So you can actually plan that. So typically the loss of hours of operation is also linked to the revenue loss, and in terms of say utility, they don't need to plan quite frequently, taking shutdowns and kind of rebalancing the load through different alternate channels. So that's what I would like to answer for this question.
Sure, thanks. Poojan, the next one is for you. So I'm combining two questions for you. First one is, do we have to use individual unit for each transformer, or can we use one unit for more than one transformer? And the second is whether the transformer monitoring system is having communication facility with customers' SCADA system, right? So I think you can combine the answer for these two.
Sure. So I'll take the first question. So each device has essentially been designed for the specific transformer, keeping in mind the different parameters that you'd actually want to monitor. So for example, like Achal was saying, there may be the oil temperature, winding temperature, oil level, current voltage, etc., that may need to be monitored. It's one device or one unit per transformer. Again, the idea for this is to actually keep it highly customized and granular, that when you're actually analyzing and reading some of this data that you have, you're able to look at it for very specific transformers at a very specific point in time, because there could be a lot of data that is being captured at different points for different sets or different assets itself, or different sets of transformers that you may be looking at. So again, the short answer to your first question is that yes, you would need one device per transformer. I believe the second question was related to integrating this with a SCADA system, correct?
Yes, SCADA or any other systems that may be there.
Right. So the device itself, the IoTX device, actually has, or our specific device actually has the ability to integrate one device typically through a Modbus protocol, through which the data is being pulled, and then it all is pushed into Motware as an application. Which means that, let's say you have an external device, which is, let's say, for example, an energy meter that you may want to integrate, you can actually do that. Again, being an RS485 port, you can have multiple devices of such type, which could be a multi-point line on a single line, sorry, versus an RS232, for example. But again, you have at least one port which can be used for integrating an external device into the device, and hence into the application itself, which is Motware. Uh, the device also, I should add, the IoTX device is actually built to be quite modular. So just like we spoke about energy meters, I mean, you could have anywhere from, or you can pick really anywhere from about 15 parameters or so, all the way up to 30 to 35, plus the energy meter parameters also. So there's actually a lot of modularity and scalability within the device to allow you to capture those specific parameters that you may want to. So, the question that I answered first was also around the range of transformers or the types of actual installations that even we have worked on and done. Actually, this is very relevant for that too, where across these different transformers and across the different ratings of transformers that we've looked at, we're capturing a very different set of parameters. So on some, it's the basic, temperature, oil temperature, winding temperature, oil level, current and voltage. Some of them actually were also capturing certain relay information, which is when certain relays have actually been alarmed or tripped. So when they're actually triggered, and what were the conditions leading up to that point of also being triggered. There is also another case where we're looking at integrating and knowing the status of a lot of other inputs into of the transformer or of the substation itself. So there could be a capacitor bank, for example, which is on or off. You could know the OLTC tap number, for example, which could be on off. You could also integrate a DGA into this, for example, which also can be taken care of with the IoTX. And then also you may want to know the temperature inside one of the cabinets of your switchgear as well. So there's multiple options, multiple parameters that can actually be brought into that one singular device to push into Motware as that singular platform, which will help you as a user analyze the asset itself with very relevant information, which is automated and through a live feed that you would eventually get.
One more input from my side, which I would like to share. Since the question was regarding integration to SCADA, since we have this as an open architecture, the platform, it can be readily integrated using API integration. So the SCADA server and IoT server can exchange data in real time through API. So that's what one of the beauty. It can actually be integrated with any. It's agnostic to the type of application, wherein it can share the data in a prescribed format for further use into any other package for maybe analysis, or it could be for kind of some charting or dashboarding, or maybe for some kind of ERP requirement. So all that is possible through API integration between the Motwane platform and the SCADA server.
Yeah, thanks, Achal, for adding that in. That's a great point too. Yeah.
Yeah, Achal, one more question for you. This is from Mr. Rabindranath Mahapatro. Whether the transformer monitoring system can be used for cooling control of the transformer?
So typically idea for this solution is typically to monitor. So obviously there is some level of automation which is already with the transformer solution, like automation of the transformer solution, wherein it is automated through some relay logic, or maybe through some kind of automation by using some dedicated controller or PLCs in that. So practically, since we are only focusing on this, but yes, the controller has got customizable outputs to be communicated. So of course, based on the requirement, it can also be done through the controller. That would be a customization at our end, but that's possible. However, it's already in place in some different form, but where it really needs to be upgraded or kind of replaced, then yes, it can be integrated to this hardware as well.
Okay. Achal, another question is, if if subsequently we enhance the transformer capacity, do we have to change the unit?
This is completely agnostic as an piece of hardware. Of course, with the rating of the transformer sensors in terms of type and quantity might vary, and that's very easily handled by the flexibility in the hardware itself. So typically, this is agnostic to any rating of transformer. So this hardware need not change. Maybe it might need a kind of any augmentation if the number and type of inputs vary. So the investment in the hardware as well as in the application is not lost. It can be kind of upgraded in future. So that upgrade path is available.
Okay, we'll take two last questions. Of course, we can continue to answer them through emails, our email IDs. So one question by Mr. Gupta is Parth Gupta is, does this device come with separate instruments to monitor OTI, WTI, phase currents, oil level, or it tapes the value from existing instruments? Pujan, would you like to take this?
Yeah, sure. I can take this one. So actually, this device in itself can be integrated with your transformer pretty much out of the box, pretty directly with the transformer itself. Of course, it just needs the right set of inputs, which is a signal input to the IoTX device itself. So it can work with your existing OTI, existing WTI, existing oil level indicator as well, oil level sensor as well. Provided, of course, the right signal output is available, which in this case is a 420 milliamp output. In the scenario that is not available, or the OTI and WTI is not of the hybrid type, then yes, you would need to replace those sensors, but those are very easily available from some of the leading OTI WTI sensor manufacturers. And we work with them very closely as well. So we can always work together to find a suitable replacement. But again, out of the box, actually the device does not need necessarily a new set of OTA WTI. Again, in the case that it does, it's very easily available and it can be replaced. And when it comes to the oil level indicator, for example, or even a actually, which typically would be a float sensor, even that too can be integrated into the transformer monitoring device quite seamlessly. You may not even necessarily need an additional sensor for that. It just depends on what the sensor is when we actually physically look at that at the transformer itself. So I think to answer your question, the integration is it doesn't necessarily need the new sensor, but it can work with the existing sensors given the right type of output, of course, that would be available.
Sure.
So this is like design keeping in view both kind of scenarios. If it's a greenfield, then of course it's like possible to design upfront. Largely, we have a lot of brownfield where this can be brownfield cases. So yes, if the existing devices are suitable to deliver the outputs in terms in required formats, then yes, and if not, then it is easily upgradable. So there are a lot of options through which we can kind of capture those parameters which are required for monitoring.
Sure. So Achal, last question for the day. This comes from Mr. Manoj Khare. Transformer thermal modeling is manufacturer specific. How effective it will be when generalized across the board?
Yeah, so a lot of simulations at backend on different type of designs are already in place. Yeah, so obviously each transformer has got some customization based on the specifics, but over a broader category, there are a lot of guiding standards which always put all these values as a limiting values. So typically this takes into considerations all of those for a particular rating, and of course we capture specific inputs for the typical transformer. Some of them are readily available in terms of nameplate and transformer specifications, and if it's a really very peculiar design, then of course in that case it can be kind of certain required parameters can be assessed from the manufacturer if it's really very peculiar design or one of its kind. But in a broader view, there are data available from the nameplate and other submissions along with the transformer. Plus, there are governing standards which which gives a guiding value for those parameters, and that's from the design point of view. And of course, then other part to that is the dynamic loading, which is the dynamic condition, which will tell you. So yes, this model, since it's on a IoT platform, there are a lot of possibilities to enhance the kind of accuracy by putting it through machine learning. So yes, even on individual transformer level, even though it is of the same manufacturer, it can be customized for that particular transformer. That is, but over a period of time when considerable data is available. So yes, the model works good across different ratings and design type. And at a later date, we can deploy the machine learning for each device to make it further more accurate.
Thanks, Achal. So I think we've taken questions. I'm sure there are more questions. I have, put our email ID in the chat. So in case, your questions have been unanswered, feel free to, email them to me. I will make sure they are answered individually, right? Also, before we close for today, a quick reminder for tomorrow, we have another interesting session on insulation oil testing for transformers, right? So we will discuss the methodology, inferences, and some of the solutions that we have, which are again connected. So hope to see everyone tomorrow same time. It's at 3 p.m. The link will be shared by Mr. Patnaik. And also thanks to all the Spark fraternity. This was a great session. Mr. Patnaik, thank you again, and hope to see everyone tomorrow. Thank you so much.